Okay, thank you everyone for joining. Today I will try and do a uh, brief overview of mapping with drones. Um, we'll cover some of the technology and some of the software and hardware and processes uh, for using mapping with drones in a humanitarian context. Um, first, drones. There are a bunch of different types of drones, and we'll go over some of those basics. Drone, for some, is maybe a little bit informal. It used to have some negative contexts. Drone was sometimes used only to refer to the use of machinery by the military to either surveil or attack targets. But in recent years, it's become used more commonly to refer to the equipment that people use for photography, surveying, and other purposes. Other terms that are more technical that you might see that are used include unmanned aerial vehicle, UAV, small unmanned aircraft system, SUAS, and remotely piloted aircraft system, RPAS. The drone system usually consists of a couple different pieces. There's the remote pilot and command. So the person usually providing overview of the operating system and controlling and piloting the drone. They usually have some sort of ground control system. And that includes telemetry that allows the signals to be passed back and forth between the controller and the drone. A controller that the pilot and command can use to control the drone and adjust its flight path, and some sort of display so that they can monitor, possibly seeing what the drone sees through its camera, and being able to observe all the details about its status. And then the drone itself has telemetry so that it can receive and send the signals to the ground control system, various sensors that might include proximity sensors that can tell it if it's going to hit something, different cameras, potentially other things like temperature sensors and velocity sensors as well. Usually some sort of payload. So in our case today, we'll be discussing drones that carry a camera as a payload. There's also drones that might be cargo drones, and so carry something like small amounts of medical supplies or other things to transport. And then some sort of control board. The drone has a computer on board that controls all those different systems and allows it to operate. The different kind of structures of drones. There are fixed wing drones that look like kind of your traditional plane type aircraft. They might look very much like a plane, kind of like the one on the right here with your traditional wing and tail. There's also something called a flying wing, the one on the left here, that looks more like something Batman might be flying, or maybe like a stealth bomber that are kind of one solid wing going across. The fixed wing drones, the lift for the drone is created by movement of air over the wing, and not only the propellers. So an advantage of these is that even if the motor cuts out, if something happens to the propeller, they can sometimes continue to glide for quite some time. So even if there's a machine failure with the motor, you can sometimes still bring them down safely for a landing. Usually, these fixed wing drones have longer flight times and are able to carry a heavier payload. But they do need more space to take off and land. You oftentimes need something more like a small runway or a large open field. There's also the multi-rotor drones. So these have been made popular by companies like DJI and other companies that have produced these for kind of your average consumer. These have anywhere between 1 and 8 or more propellers. and it's the propellers that provide the lift. So as soon as the propellers stop spinning, the drone loses lift and will fall from the sky. So that can be, there's less redundancy in the event of a mechanical failure. As I mentioned, these multi-rotor drones can have any number of combinations. The quadcopters with 4 propellers are some of the more common consumer drones, but they can have many more. The more props they have, the more redundancy in the case of failure, and the heavier payloads they can carry. So if you see one of these carrying like a large video camera for movie making, oftentimes those will be the hex or octocopters with 6 or 8 propellers. And with the more propellers, so with 6 and 8, if one of the motors fails, oftentimes the drone can continue to fly, even if 1 or 2 of those blades stop spinning, which can be helpful in the event of a failure or emergency. Usually, these multi-rotors have shorter flight times, with more motors spinning and having to create all the lift. It just requires more energy, so the batteries are used up faster. But luckily, the multi-rotors, the advantage is they can take off and land in a very small area. They're able to take off and land vertically, so you only need a very small amount of space to take them off. There's also hybrid drones, which are a mix of both of these. So they're also known as VTOL, vertical takeoff and landing. There's a couple different types. The one on the left is known as a quad plane. So it has both the kind of the quadcopter propellers, but then also can fly as a plane. The one on the right is a tail sitter, so it can take off vertically and then through the mechanics can orient itself facing forward once it's in the air and fly like a plane. These have some of the advantages of both. So they can take off and land in a very small area, but then have sometimes the heavier payload and the longer flight times of the fixed wing due to the wings creating the lift during flight. But they are more expensive and more technically complex to build and to operate. Humanitarians have found interest in using drones. A couple of years ago, there was a study where they they surveyed a bunch of different humanitarians and asked what they're interested in using drones for. Mapping, which we're discussing today, came out as the highest level of interest, but also for monitoring, for search and rescue, for delivery, for delivering public information, and then a few other less well-known options. The Red Cross Red Crescent movement has been exploring the use of drones in a variety of ways and by a number of different national societies. If you'd like to read more on that, there are 2 studies that we've produced. One, Aid from the Air, just a overview of all the different national societies that have used drones and how they've used them that we know of. And also then Images from Above, which looked at aerial assessments generally, but then also included a focus on how drones can be used for aerial assessment. And both of those are available online. You can download the PDF or you can email me and I can send you the PDF as well. So why drone imagery? So temporal resolution, or resolution over time. This is 2 images. One on the left is the commercially available, publicly available satellite imagery from Digital Globe. And the one on the right was drone imagery taken at the same time that that satellite imagery was publicly available. And you can see that there are a lot of changes that have occurred in the image. There's additional buildings that have been constructed around the pond area. And it looks like other structures and houses have been built as well. And so the drone imagery is, taken the day you fly the drone, is immediately available, whereas satellite imagery, at least what's publicly available, can sometimes be months or even years out of date when you have it. Here, from a couple of years ago, when the TTL program had an office in Tacloban. Here you can see their office compound. On the left, the satellite imagery, and on the right, the drone imagery. And you can see that there's been changes that are not visible in the satellite imagery. Also, drone imagery can be useful because it is can be unaffected by atmospheric conditions, so clouds and other conditions. Here's a satellite image of a barangay in the Philippines. You can see it's obscured. It's covered by some clouds. A satellite image from a different date is also covered by clouds. Oops. In drone imagery, oftentimes, you're flying below these clouds, so it will not be obscured by clouds. Also, drone imagery can be useful because of the spatial resolution, so the level of detail that is visible in the image. Here's a satellite image of that previous barangay without cloud cover, but you can see that it's quite blurry, that it's hard to see the details of the individual houses. This is drone imagery of the same barangay, and you can see that the level of detail is much higher. You can very easily pick out the individual buildings. You can see details that are not visible in the satellite imagery. So when trying to see all the details of an area, drone imagery can be very useful in seeing all of those. Here's another example from Leyte, where it's quite dense. The houses are very close, and it's hard to see the individual houses in the satellite imagery. But then in the drone imagery, the detail is much sharper. It's much easier to see everything. Here's an animated GIF showing the same thing, the difference between satellite imagery and the drone or aerial imagery, and the level of detail being much higher. So the drone imagery can help you create better base maps. Here is an example of OpenStreetMap data showing the road, river, and buildings that people were tracing just from satellite imagery, having challenges being able to trace the individual buildings. And then with drone imagery, it made it easy for them to fill out all the individual structures and buildings and details of that barangay, including some of the smaller paths and other details. Here with satellite imagery, again, showing kind of difficulty in tracing the individual buildings, and then with drone imagery, being able to map out in much more detail that barangay. Those base maps can then be a canvas for much more. So once you have all your buildings and roads traced out, you can collect additional data. This is from a project in Africa where they went out and collected details on the condition of the structures And so those in good condition are green, those in poor condition are red, yellow being intermediate in between, and being able to see the different parts of the city and where people were maybe more vulnerable or living in kind of worse conditions, and being able to visualize that on a map. Also adding addresses for response activities, understanding things, details for evacuation maps, things like that. All sorts of disaster preparedness activities can benefit from having accurate, detailed base maps. Also for planning and development. So if there's any sort of municipal projects or development planning, having a detailed map can be very useful for that. Here's another example, this one from Uganda, where they, you can't see the individual buildings because the map is too zoomed out, but they recorded the roof type. And so some of the roofs are, the CGI or other kind of fire resistant materials, while there are also a lot of buildings with traditional grass thatch tops. And so they mapped out these traditional roofs, and knowing that they are at higher risk of fire, we're able to understand areas of increased fire risk in the municipality, the areas where there's high concentrations of these traditional roofs. There are some limitations to drone imagery. So you are flying a piece of machinery in the air. So there's some amount of risk of harm to people and property. That's why safety is very important. If something goes wrong, if the drone crashes and hits a person or a house or a car or something, it can be quite dangerous. They are limited in the area that they can cover. Sometimes the quadcopters are limited to about 30 minutes of flight time these days. So you can only map so much in that time. And also, usually there's some sort of regulations about flying these drones that may limit your flight to line of sight. So that the regulation that you're supposed to keep this drone where you can see it at all times. And so you can only fly it so far from your takeoff point, and also altitude limitations. So you can only fly it at a certain height or below, which limits how much the camera can capture of the ground in any given picture. The higher you are, the more ground you can cover with a single image. Drones can be damaged by rain or excessive wind. If you have enough money, you can buy industrial level drones that can fly in the rain and operate in very rough conditions. But a lot of the kind of consumer level drones, like the DJI drones that are available to most people, tend to be damaged in the event of rain or wind. There's also cost and training requirements. And I see there's a question in the chat about, do you need a license to operate or fly drones? And that varies from country to country. In the US, and I believe in the Philippines as well, if you're operating a drone commercially, you do need to be registered. In the US, the Federal Aviation Authority has a test that you need to pass before you can then register your drone and fly commercially. In the Philippines, I think CAP, the Civil Aviation Authority of the Philippines, they have some rules around getting licensed to fly a drone commercially. Usually in countries, if you're just flying it recreationally, the rules are built a little bit easier. Usually there's less rules around the registration and the licensing for that for personal use. Um, a key part of drone mapping is community engagement. The Philippine Red Cross is great at community engagement. Um, so this shouldn't be a big issue for you. Generally, there's a positive community response. Usually people are interested to learn about what's happening, to see the technology in action, and are excited to kind of be part of it. But it's always good to check in advance with the people and you're going to be mapping, with the area you're going to be covering, and allow a community to refuse to be mapped if they don't want to be part of some sort of activity like this. So part of drone mapping is the gathering of images. There's a couple different sensor types that a drone can carry. There's digital RGB, red, green, blue, which is your standard kind of digital camera, and that's the one that we'll be focusing on. That's what most drones kind of come equipped with standard if they have a camera, and is most common. There's also near infrared or infrared cameras that collect additional wavelengths of light. And these can allow for some additional analyses. If you have studied GIS, you might have studied NDVI, natural vegetation difference index, and that uses some additional bands of light to help analyze the growth of crops and other vegetation. And so that's an additional use. Drones can also carry thermal cameras, which can be useful for like firefighters to understand a structure and where the fire is getting out of control, where it's being put out. Also for search and rescue, if you're looking for someone who's lost in the forest or lost in the wilderness, you can use a thermal camera to help more easily identify someone who might be lying down in high grass or vegetation, being able to pick out the heat of their body instead of trying to visually see them. And also, while there's LiDAR, which is used to kind of do 3D mapping, those sensors, many of them are still too big to be easily carried on a drone, but are constantly being made smaller and more inexpensive. So I think we'll see more of those in the future. Mapping requires taking a lot of images. So you can only capture so much of the ground from the drone at any given time. And so you fly back and forth across the area of interest, collecting many images of the ground. The images need to have overlap and side lap. So overlap is the amount of that images intersect as you're flying in a single path across the area. And then side lap is how much the images cover each other between the rows. So once you turn around and the drone starts flying back in the other direction, covering ground a little bit further along, the amount between the rows is the side lap. So here you can see a diagram explaining overlap, where at the top 0% means that there are no features in an image that are included in another image. Each image covers unique parts of the ground. And then as you increase from 20% and then to 70% overlap, you can see that the amount of duplication between the images increases. It's necessary to use a mission planning software. The mapping flights are automated because it's really probably impossible to fly a drone manually in the right pattern and triggering the camera at the right times in order to get that complete coverage with the right amount of overlap across the entire area that you're trying to map. The drone needs to fly a very exact kind of grid pattern and needs to trigger the camera at exact intervals to provide a consistent overlap. And it would be very hard to do that if you were flying manually. So with a lot of these softwares, you provide the settings, the parameters, usually the altitude, so how high above the ground you want to fly, and the polygon that defines the area you want to cover. And then the software will calculate how many passes back and forth the drone needs to make and how often to trigger the camera. And usually it'll also estimate some things like the time that it expects the mapping mission to take and how many batteries that the drone might need to complete the full mission. After collecting all the images, there's image processing. So here you can see in the first image that you have a drone that's flying back and forth in these lines, collecting images as it goes. Then you have maybe several hundred or even several thousand images covering the area with the overlap and side lap. And then the image processing stitches those images together like a puzzle into a single image that can be then used like a map in your GIS or mapping software. The software that we like to use is called OpenStreetMap, and so it can take all those individual images and create kind of two primary outputs. The one on the left being your ortho photo, your orthomosaic, where the multiple images have been stitched together into a single image. And then it can also create a digital surface model. So actually using the multitude of images and being able to compare the pixels between the images, it can produce a map of the height of the features above the ground. So in this case, being able to see those building roofs, the trees, and the valley kind of in the lower left there. And so you can build a rough 3D map of an area actually using from these 2D images, which is pretty cool. OpenStreetMap has a website piece that allows you to more easily interact with kind of the processing software. And it's open source, so anybody can, if they have the skills and can install this and run it. For the crib mapping activities for this project, I'm going to set this up for the team so that they can have access to it and process the imagery. After you've processed the imagery, it can be useful to share it. One of the platforms that we like to use is called OpenAerialMap. It's just an open service, a website that people can upload openly licensed imagery, so imagery that's publicly available, and it makes it available as a map layer service. So once you upload the image, then you can access a URL and then load that image as a map layer into an OpenStreetMap editor or into your GIS software or anything else, as long as you have the internet connectivity to internet connection to access it. For using the image, you can, once it's processed into that orthomosaic, the orthotiff, you can load it into a GIS software. So like Quantum GIS, QGIS is an open source free GIS software, and you can load it as a layer into that, and then either make a map or trace features from it or use it for other purposes. You can also use the imagery to trace into OpenStreetMap. So OpenStreetMap being a community-built open map of the world that allows you not just to view it like Google Maps, but Google Maps only allows you to interact with it via their website and their apps. With OpenStreetMap, you can actually access the data itself, and so download it to do your own analyses, make your own maps, do whatever you want with it. So the drone imagery, if you're if you've uploaded to OpenAerialMap, for example, you can view it as a base layer in your OpenStreetMap editor. And as you're tracing these features, adding details and sharing it with all the other users of OpenStreetMap, you can get those additional details by using the drone imagery. And then after, using these tools like the OpenStreetMap editors or using QGIS, you can use the maps for a variety of purposes. So here under TTL program, they used the maps in kind of disaster preparedness programs, disaster planning exercises, and it's a good situational overview, being able to view the current up-to-date situation in the barangay in terms of the location of the different houses and roads and things. Some important reminders, people and mission first. So, you want people to be safe, whether it's your team or the people you're flying over. So you always want to be careful to avoid accidents like those ones pictured here. We'll go into more detail with kind of the team that is doing the mapping for the program. But you want to be very aware of the safety features of your drone, of the limitations of your drone, and of the conditions, both your own conditions and the environmental conditions. It's important that the pilot be well rested and hydrated and ready to fly. It's important that your equipment be in good condition and well maintained and ready to fly. And it's important that you're aware of things like wind and storms that may impact your flight, and being aware of things like your battery level and other conditions. You want to avoid accidents. There's a document, the Humanitarian UAV Code of Conduct, available at uavcode.org, that kind of lays out a bunch of the things you should think about when flying a drone as a humanitarian. A lot of this is stuff you're already familiar with if you're a Red Cross volunteer, have been working with the Red Cross. Things like identifying an appropriate solution, doing no harm, making sure you engage with communities, that you're responsible both when flying, when managing the data, when establishing partnerships. And so if you're interested, you can read more on their website. I think it's some really really good guidelines, some really good things to think about when flying drones and when doing humanitarian work are included in that code. And remember that we're trying to amplify people with technology. Yeah, drones are a cool piece of technology, are fun to fly, but ultimately it's about helping people do their work better, whether that's better disaster planning, better disaster response, better community work. We're using this technology to help make people work better, work more efficiently, to help them do their jobs. It's not technology just for the sake of technology. And sorry, I know we've gone a little bit over. I didn't expect the long introduction, but I enjoyed hearing where everybody was from and their interests. So now I'm happy to answer any questions, and I see there's been a few in the chat. And so thank you to the people who added some details about CAP. that they encourage all drone pilots to get a license for safety reasons and awareness. And then for commercial, for humanitarian, there's not really an established law or policy. I guess they fall under kind of the general use case. But you need to fly no more than 400 feet above ground level, 122 meters. Otherwise, you need approval from CAP, from the authorities. And that's the same in the US. The altitude cap, altitude maximum is 400 feet as well. Also, there are certain areas, somebody noted, that you're not allowed to fly. So within certain distance of airports, you are not permitted to fly without making sure you get permission and authority and have communication with the airport authorities. Also around places like military bases and highly populated areas. And there's a question from Arthur. What are some implications in the utilization of drones for humanitarian operations, especially in countries, communities with less robust or even non-existent regulatory frameworks for data protection and privacy? So I always like to encourage people to try and apply best global practices when operating somewhere, not just the best local regulations or frameworks. So in the case that there are no regulations in a country around the use of drones, but you have the opportunity to fly there, you should still probably look at some of the regulations in place in other countries. So like the 400-foot maximum flying altitude without permission, other permissions, and also the line of sight flight are both good things to follow. If you can see your drone at all times, you're more likely to be able to avoid an accident. And if you're keeping at 400 feet or below, it's easier to avoid manned aircraft or manned helicopters, which usually are flying higher than that. Even if there's no data protection policies around the collection of aerial imagery, you'll want to be aware of kind of what you're doing. You don't want to be flying low enough and then releasing, pictures of somebody, maybe taking a shower, taking a bath in their backyard, or using, doing something, changing outside or something like that. You want to be careful of not exposing someone or releasing imagery that's high enough detail that it is invading someone's privacy and going beyond what you need to trace buildings, to trace roads, and the features that you need for mapping. And then a second question, how do you manage drone data in terms of interfacing it with proper archiving? That can be difficult because drone imagery can be quite large. It can be a lot of data, a large file size. If you have thousands of images, it can be hard to store that long term, or it can be expensive to store that long term. And also, if you're making it available, it can sometimes incur. It can sometimes have hosting costs. So if you have a server somewhere, or paying for cloud storage, all that can have costs. So usually, like, you just need to establish maybe some guidelines for your organization for the number of years that you plan on storing kind of maybe the raw imagery, and then the number of years you plan on storing the kind of the imagery products, and where you're going to store that. Usually some combination of maybe some local hard drives. External hard drives can be inexpensive these days, but also can fail, especially if stored in the wrong, in a hot room, or maybe if they get moisture damage. So having backups is always good. At American Red Cross, I use Amazon S3 web storage for some of our longer term storage needs. Once it is uploaded, just having it sit on their servers is relatively inexpensive for large amounts of data, and it only incurs kind of larger costs when you then download the imagery. So for something that you maybe don't plan on needing again, like some of the imagery sets, it can be economical to store it on some of these different cloud providers for a number of years. A comment from John Eric. We need to be aware and understand that international laws and policies on drone operation, especially local context of the country, communities will be operating the drone. Coordination with the community is important, and we need first to get their approval consensus before the drone flight, considering that we'll be taking videos and photos of the locality. Yes, just as if you were to go into a community and plan a project or interview people, and you need to have a plan in place for kind of what questions you're asking people, why you're asking those questions, and how you're going to protect their data, especially if you're collecting sensitive information about their health status or their government documents or their family size, things like that. You need to safeguard that information appropriately. With drone imagery, you're also collecting potentially sensitive information, and a community might have a reason that they don't want to be mapped or don't find it useful. And so you need to listen to those concerns and try and hopefully address them. But also in some cases, if a community doesn't want to engage, then oftentimes best to respect that decision and find an alternate way to work with them. And also drones have been around for some time now, but are still, I think, like a new technology in some respects. There are still kind of developing regulations, developing laws. Some people may not know a whole lot about drones yet. So it's very important to operate them safely and ethically. If someone knows very little about drones, and then they read a news story about a drone crash in their community or an invasion of privacy, like that will shape their opinion of drones a lot. You don't want the one time they hear a news story about drones to be the time the Red Cross invaded privacy or crashed a drone. So you want to make sure that you operate safely for that reason as well, to make sure that to help people understand that drones can be useful and that can be operated safely. In countries where they're still working on developing the drone regulations, you want to definitely prove that organizations can operate drones effectively and that there's good use cases for drones. Having those good use cases, having examples of how drones can be used effectively and safely can help influence the creation of laws and regulations that make sense and that are useful in making sure that everyone is safe, but also that everyone can effectively use this technology. Are there additional questions? If you have one, you can also unmute and speak or type in the chat. And if one of your questions was already answered, but I didn't answer it fully, or there's more details that you want me to provide, please also let me know.
Hello, Dan. This is Arthur.
Hi,
Hello,
Arthur.
if I may just share quickly, my first introduction to the drone system was when I was doing graduate school, and there was a short introduction, although it's in an archaeology class, but our professor introduced us to the GIS system. And in terms of back then, our greatest difficulty in doing field work using drone management and storing data is really when we apply the interface of the different platforms in different GIS systems that is compatible to the initiated data that was already processed during field work. So I'm just wondering whether during if whether um, you have such same experience, especially in processing data, because sometimes when different persons use different types of drones and they attach processes will have to pre-configure the software that you will be using for data analysis, then interfacing is a bit a challenge, especially when the team is tasked to come up with just one image map that comes from different formats and platforms of the file. So that's where I'm actually coming from. Thank you.
Yeah, so with their studies, I'm not sure if you were using any of the kind of the more advanced sensors. It can be quite difficult to conduct certain analyses with like the multispectral cameras and images if taken over different periods, because it can be difficult to compare effectively images from like March to images in July. If the drone was maybe at a slightly different height, if the camera was calibrated a little bit differently. So there can be, for kind of some of the scientific purposes, there can be challenges that you have to prepare for. Also, in processing the imagery, so the drone has just a commercial GPS, which are not accurate, maybe within 10 feet or so usually, but not perfect accuracy. If you're using the drone for like engineering surveying, there are certain equipment you can buy, including like ground stations that will record GPS and then help you correct or adjust the GPS of the drone so that your images are more accurately positioned. But even then, there might be some differences because the drone is moving through the air and has like a a GPS that fits on a drone. Um, and so can be some inaccuracies there. One of the things people can do is they can use something called ground control points. So they will go out and either put down um, like a sheet or some sort of a target basically on the ground that can be visible in the drone imagery. And then they'll use like a surveying grade GPS unit to take the very exact positions of that target. And then when they process the imagery, they can use that known location to correct the final image. So when the drone imagery is being processed, if it's 100 images for your area, each of those 100 images has a GPS coordinate, and then it uses all 100 of those coordinates to kind of position the imagery and align it to the ground, to the map. As it's doing that, it's not perfect. So sometimes you'll put your drone imagery over the satellite imagery that's available, and it won't quite line up. There might be like your house will be offset a little bit, and that's just because each of these different images, each of these different processes has potential for error in slightly different ways. And so when you're working to make your map or to do your final analysis, you just have to try and adjust for that. So sometimes if you're tracing an OpenStreetMap, you might just kind of adjust your drone imagery a little bit so that it lines up with the maps and the roads and buildings that people have already traced, and then use it there. You might have to go out and correct your imagery. So within like QGIS, you can actually transform your imagery. Like if you go out and measure some of the like, oh, that road intersection and that tree and that that trash can that I can see, like I'm going to go out and measure the more exact GPS coordinates. You can then kind of adjust your image to be more accurate, more true to the ground truth. Yeah, depending on the type of error and the type of thing you're trying to correct for, there's some different techniques to get your different sources to align.
Thank you so much.
Great question. Thank you.